This video is about the discriminant. What the discriminant is, it's the part of the quadratic formula that is under the square root sign. It's b squared minus 4ac, not the square root of b squared minus 4ac, just the b squared minus 4ac. If you haven't watched the quadratic formula video, you might want to do that before you watch this one. What the discriminant is good for is it helps us determine the nature of the solutions before we actually do the problem. What nature of the solutions refers to is what type of answers you're going to get. If you do this b squared minus 4ac and it turns out greater than 0, then you know you're going to get two real solutions. If b squared minus 4ac equals 0, then you get one real solution. And if b squared minus 4ac is less than 0, then you know you have two non-real solutions. And the way we're going to verify this is just to look at the problems we've already done on the quadratic formula video. We did this problem on the quadratic formula video and got these answers. These are two real solutions. 4 and negative 1/3 are real answers. So let's just see what happens when we do b squared minus 4ac. You know that this is a, this is b, and this is c. So I'm going to plug negative 11 in for b, 3 in for a, and negative 4 in for c, which looks like this. Do this arithmetic. Negative 11 squared is 121. Negative 4 times 3 times a negative 4 is a positive 48. Add that up as 169, which is greater than 0. That was our rule back here that said if it is greater than 0, then we know we have two real solutions. Another example we did on the quadratic formula video is this problem, which turned out to give us one answer. It is one real solution. Let's verify that by plugging in our a, b, and c. A is 4, b is 20, c is 25. Plug those in, put 20 in for b, put 4 in for a, and 25 in for c, and we end up with 400 minus 400 equals 0. If b squared minus 4ac equals 0, we know we have one real solution. Third possibility is, here's our problem. When we solved it using the quadratic formula, we got this, which was imaginary. That's non-real. We have two non-real solutions. Let's verify by plugging in our a, b, and c. b is 3, a is 2, c is 5. Plug all that in, and we have 3 squared minus 4 times 2 times 5, which is 9 minus 40, which is a negative number. Negative 31 is less than 0, and that's what tells you you're going to get two non-real solutions. So let's do a couple problems, see if we can figure this out. Here's the equation. I just want to know what the nature of the solutions is. I'm not asking you to do the entire quadratic formula. Just do the nature of the solutions, which means we just want to look at b squared minus 4ac. Here's our list of a, b, and c. So negative 7 is going in for b, 3 is going in for a, 4 is going in for c, and this is what it looks like. Negative 7 squared is 49. Multiply this together is 48, so 49 minus 48 is 1. 1 is greater than 0, and whenever it turns out to be greater than 0, we know that we have two real solutions when we actually do the whole quadratic formula. Another example. A, b, and c are listed there. Let's plug them into b squared minus 4ac. b is 3, a is 4, and so is c. Plug all that in, and you're looking at 3 squared, which is 9, minus 4 times 4 times 4. So that's 9 minus 64, which is a negative 55, which is less than 0. And whenever this value works out to be less than 0, we know that we are going to end up with two non-real solutions, which means we're going to have answers with I in it. Last example. 9x squared plus 12x plus 4 equals 0. Here's our listing of a, b, and c. That means b is 12, a is 9, and c is 4. So arithmetic looks like this. 12 squared minus 4 times 9 times 4. 12 squared is 144. And if you multiply 4 times 9 times 4, you also get 144. When you subtract those, you get 0. And anytime the b squared minus 4ac equals 0, we know we're going to end up with one real solution. So that's the discriminant. It just will tell you what type of solutions you will get before you do the whole quadratic formula.